Okay, so we're going to look at in this video the types of reactions in organic chemistry. This generally comes up as a question 8 on your leaving cert, and a few people had messaged me to say they wanted to go back over this. So this is something we're going to have a quick look at. The first thing you're going to do before we look at the exam papers though is a quick revision over this. There's an awful lot in it, can get quite complicated, so let's have a quick go. I tried to summarize all the main reactions for you. I'm not going to spend a huge amount of time on this particular part. But all of these form a new molecule. You've got substitution reactions, you have addition reactions, and obviously with substitution reactions you remove something, you replace something else. Addition reactions add on something. Elimination reactions, you take something away from the molecule, like water for example. You've got redox, oxidation reduction, using the oxidation reducing agents to convert one family into another. You then have the reactions of alcohols and carboxylic acids, and these can act as acids. In other words, they're a proton donor. And then finally you have organic synthesis. And then for your leaving cert, here are the main 5 experiments that you have got to deal with. So the preparation of soap, which we've done, the reactions of ethanol and ethanoic acid, which we didn't do in the lab, but I've sent videos on, and you need to just make sure that you look over those. It's not a big experiment, it's a couple of test tube tests. But definitely look over those. The oxidation of phenylmethanol to benzoic acid, well, there's 3 experiments in that, and we've done those. You have to oxidize phenylmethanol to benzoic acid, and then you have to recrystallize benzoic acid and measure the boiling point of benzoic acid. So those 3 there are one experiment. And then finally to separate ink using chromatography, which you probably did in junior cert. But is also there on the leaving cert. So let's have a look at the very first one. So what we're going to do is we're going to go through each one of these main reactions fairly quickly because we've done them already, but it's good to revise over. We're going to start with substitution. Excuse me. Now substitution is the biggest of them all, and I've tried to split it up here for you just to see how it's laid out. So substitution is split up into 2 types of reactions. You've got halogenation or halogenation, and you also have esterification, the creation of an ester. So in halogenation, that's just the adding of a halogen, which is in group 7, chlorine, bromine, iodine. And you need to know a mechanism. There's only 2 mechanisms you need to know. This is the first mechanism. And you are going to react CH4, which is methane, and chlorine. So that's the first part of halogenation. The second part then is esterification. So that's the creation of an ester. There is 3 parts to esterification. There's a condensation reaction. In other words, where an ester is formed via condensation. You have the reverse of that, which is hydrolysis. And then if you do the reverse again, except you do a base hydrolysis, in other words, you do the hydrolysis in the presence of a base like sodium hydroxide, you end up producing soap, which is saponification. So there's the 3 parts to esterification. We're going to look at each one of these in turn. So we'll start with halogenation, or the adding of a halogen. So this is fairly straightforward. You have CH4, that's what we're going to start with, and you're going to react it with chlorine gas. And what happens here is your chlorine, and there's all H's surrounding this of course, and what happens is your chlorine here is going to replace that. Remember what we're looking at, substitution reactions. So when that happens, you end up producing your methane molecule again, except this time it's got a chlorine on it, and you've produced hydrogen chloride over there. So this particular molecule here is what's called chloromethane. And you've obviously produced hydrochloric acid, or hydrogen chloride. So that's the basic reaction. That's it in basic format. Now what you have to do is you have to look at the mechanism. The mechanism is looking at this basic simple reaction and seeing what happens at every single step along the way. And again, very, very quickly we'll run through this. I know we ran through this in class. Let's go through it again. So initiation. So this is the first part. This is where the UV breaks down the chlorine. So when the UV breaks down the chlorine, it's breaking down the bond. So what you have is you have Cl bonded to Cl, and a bond, a single bond in chemistry means that there are 2 electrons shared. And when these 2 electrons are shared, the UV light breaks the bond, they end up freeing. So the direction of the arrows is that way. You end up producing chlorine with an unpaired electron and another chlorine with an unpaired electron. These two things here are what's called free radicals. They have an unpaired electron. So that's the first step, UV light. The second step, propagation. This is where chlorine attacks CH4, taking a hydrogen. And just a little bit of space here. So many notes here, this is going slow. Oh, there we go. Okay. So now what we have is we have our methane molecule. So when we draw our methane molecule, what happens then is our chlorine atom, or our chlorine free radical, comes along to our methane. And the chlorine atom attacks the methane molecule. And when it attacks the methane molecule, essentially what it's doing is it's dragging the hydrogen away. So as it attacks this, the hydrogen leaves. When the hydrogen leaves, you end up with this. There's your free radical there, and your hydrogen joins onto the chlorine, and that's what you end up with. So now what you have here is what's called a methyl, not a methane, a methyl free radical. Again, with an unpaired electron. It's methyl because it's CH3. That's the second step. The third step of propagation is the methyl free radical. In other words, the CH3 will attack chlorine, Cl2. So next we have our methyl free radical, like that. And then you have chlorine, and this electron here starts attacking the methyl free radical, and you end up producing chloromethane. So the chlorine joins on, and you're left with Cl left over, because if this one joins on here, then you're just left with a chlorine that's unbonded, and that's what this is. It's unpaired and unbonded. So what's this substance that we've got here? This is simple chloromethane. And then finally at the end, we've got free radicals, and atoms then will form molecules. So this is termination. So this is the final step. So when you look at termination, there's a couple of different ways that termination can occur. The first way it can occur is where you have a chlorine free radical plus another chlorine free radical. Remember, there's many of these floating around in solution, and these two free radicals will form together and form basic chlorine gas. The other way this can happen is if you have a methyl free radical like this and another methyl free radical. So there's loads of methyl free radicals floating around in this reaction, and this one here, when you put the two of them together, will give you C2, and that's H6. So this here is ethane gas. And then finally, the third way of doing it is when you just actually have a chlorine and a methyl free radical. So if you have a methyl free radical like this plus a chlorine free radical like that, then it will just join on, and you end up with CH3Cl, which is what we had up above, and that there is your chloromethane. So again, the first time around it is quite confusing, takes a lot of work, but you know, it's not too bad. So now what we're going to do is we're going to move on to esterification and look at the three parts. So again, going back up to what we're trying to do here, we've done our halogenation, and now we're on to esterification, the three parts of esterification. So let's start with the first part of esterification, which is your basic condensation reaction. In this, I just grabbed that equation just to help you. So basically, simple esterification is when you take a carboxylic acid and you react it with an alcohol, and then that produces an ester and water. So what I've done down here is I've drawn a basic carboxylic acid. So this is your acid. You know that by the C double bond OH. This is your alcohol. And again, you know that by the OH. And just for the sake of this example, I'm going to get rid of the OH. And I'm just going to rewrite it as HO. It doesn't really matter what way it's written down. We generally write it as OH, but you'll see why in a second. So what we're going to do is when these two things react, you end up with this part of the acid reacting with this part of the alcohol. And as you can see, these two things together will make H2O. So this is where your water is coming from. So here's your water on the right hand side. Now what's happening after that? So what happens is the rest of this molecule here, so the H is gone, the rest of that molecule will join on in this place here. So that's the procedure. So what I'll do is I'll rub out the OH and the water is gone. And then what we have is an O with a CH3 around it. So the O with a CH3 joins on here, an O with a CH3. And this is what this becomes on this side here. This is our ester, an O with a CH3. So that's how that's formed. Just return this to where it was. So again, there's your carboxylic acid, your alcohol, HO or OH, and then you end up forming your ester. Your ester, of course, is COO, and your OR in this case is CH3. So that's the basic condensation reaction for esterification. You'll notice that we have an reversible reaction, which we will look at in a second. So when you reverse it, that's going to be hydrolysis. Okay, back in 1 second, I'll put some more equations up. Hydrolysis, again, it's the reverse of the esterification condensation reaction we've just seen. So again, we're starting with our ester here. We're reacting with water, which is where the hydrolysis part comes from. And again, it's a reversible reaction, and that is going to produce our acid and our alcohol. So that covers esterification for hydrolysis. Of course, you can do this hydrolysis except under basic conditions. So again, if you take your ester, C double bond O, O, and then let's say an OR group, H5. So this is an ester. And if it's base hydrolysis, that means you're going to react it with NaOH, strong base. This particular substance here is an ester, so this is ethyl methanoate, and then when they react, you're going to end up with this molecule splitting up like that, and you end up producing C double bond O, O, and Na, and then what's left is the OH and the C2H5, which of course produces C2H5OH. So this one here is ethanol. So again, you're producing your alcohol again, but this time, this one here would be a methanoate because it's only got one carbon. This one would be sodium methanoate. And this here is, again, an ester. Of course, here is the start of the production of soap. So that finishes that particular part. Let's move on to the next video.